Today we are graphing and interpreting linear equations. How do I graph and interpret linear functions is the essential question. A linear equation gives you a linear function. Learning intention. I'm learning to graph and interpret linear equations. You've got 3 warm-up questions. Solve and identify the number of solutions. So if you're going to solve and identify, what does it look like? Pause the video and do those first 3 warm-up questions on your own. Well, I do hope you tried and that you're only checking your answers. So as I distribute, I end up with 10x plus 8 is equal to 10x plus 12. What do you notice? If you don't see it, let's go ahead and we will subtract 10x from both sides. I end up with 8 is equal to 12. Is 8 equal to 12? No, and it will never be equal to 12. That means I have no solutions. Okay, try the next one. If you didn't do the first one on your own, pause and try this next one. Okay, let's distribute again. 1/2 of 12x is 6x. Minus 1/2 of 10 is 5 is equal to 6x minus 5. What do you notice? Both sides are the same. So this is infinite number of solutions. So none, infinite, the last will be one solution. Let's start with subtracting 4a from both sides. Negative 3 plus a is equal to negative 10. I'll add 3 to both sides. And a is equal to negative 3. A is equal to negative 7. Negative 10 plus 3 is negative 7. And this is one solution. Okay, hopefully you were able to get those 3 and remembered. When we go into systems of equations, you'll find the same 3 things will happen. Let's go to the next, where we're going to graph the following linear equations, graph each on the same Cartesian plane, but use different colors. So let's start with the first one. That's the good old y-intercept form. Where do I begin? If you said at 3, you would be correct. How do I move? Negative 1/2, which is down 1, and right 2. So I start at 3. I go down 1 and right 2. Here's my second point, down 1, right 2. I could go on to infinity that way. Line number 1. Okay, let's look at the second line, the second equation. I've got a coefficient of negative 3, I've got a coefficient of 6, and I've got a constant of 18. What I know is 3 and 6 both divide evenly into 18. This is the instance where I could easily find my two intercepts, my x-intercept and my y-intercept. So, when x is equal to 0, negative 3 times 0 plus 6y equals 18. 6y equals 18, negative 18. I left out my negative sign there. And y will be negative 3. So the first point is 0, negative 3. 0, negative 3. For my second point, I will have y is equal to 0, negative 3x plus 6 times 0 is equal to negative 18. Negative 3x is equal to negative 18. Divide by negative 3 and x is equal to positive 6. So this point is 6, 0. I now have 2 points and I connect them and I have my line. Okay, so those two you will see on your next test, where you're in slope-intercept form or in standard form and finding your intercepts. The third one is what we call the point-slope form. Now, this is my M, this is how I move. So I go up 3 and right 1. Where do I begin? Remember, this is where you think opposites. So as I'm looking at it, with my x value, I've got negative 3. The opposite of negative 3 is positive 3. With my y value, I've got positive 4. The opposite of positive 4 is negative 4. There's where I begin. This is how I move. 3, negative 4. I go up 1, 2, 3. I go right 1. And here's my next point. 1, 2, 3, right 1, and I can keep going forever and ever and ever. And there are your 3 lines. 3 different forms of your linear equation, 3 lines. Okay, now we're going to analyze some graphs. The graph below models Craig's trip to visit his friend in another state. In the course of his travels, he encountered both highway and city driving. Based on the graph, during which interval did Craig most likely drive in the city? Explain your reasoning. Okay, so if you're driving in the city, do you drive faster or slower? Well, you have to drive slower than in the country. So would that make your slope, which is your speed, greater or less? Well, that would make your speed less. So where am I looking at that slope? This is a 0 slope, which means that what? But let's look here. This is your smaller slope. So it's between D and E. And this is because the slope is less steep. Okay. Explain what might have happened in the interval between B and C. Between B and C, what has happened? It's flat. That's a zero slope. So the time is going on, but the distance has stopped. That means he's stopped. Okay, it's for about 1, 2, 3 hours. So Craig stopped. To eat and visit a friend. Okay, 3 hours just to stop. That might be a little bit long. 3 hours just to sit and eat might be a little bit long unless you're eating with a friend. Determine Craig's average speed to the nearest tenth of a mile for this trip. So remember that will be our slope, which is the change in y over the change in x. This first point here is the point 0, 0. What is the last point? Well, this will be 7, and then I go up to 230. So in this case, I would actually start with the second point, and I would have 230 minus 0 over 7 minus 0, which is 230 divided by 7. And I end up with 32.857. I'm rounding to the nearest tenth. 32.8 or 32.9? 32.9 is correct. So this is approximately 32.9 miles per hour. That's not very fast, is it? I think it has to do with that 3-hour stop there, actually. So, hopefully that made sense, and we can go on to the next one. The next one is thinking again. The graph below represents a dog walker's speed during a 30-minute walk around the neighborhood. Which statement best describes what the dog walker was doing between 12 and 18-minute interval of his walk? So where is that 12 to 18-minute interval? Here's 12, here's 18. What is happening? Is he walking at a constant rate of speed? If you notice, the time is increasing, the distance is not. Is he increasing his speed? The time increases, the distance does not. Is he decreasing his speed, or is he standing still? He was standing still. How do you know you're successful? You know you're successful when you can graph linear equations and interpret the graph of a linear equation. So, linear equations, we're looking at graph and interpret.